Hi everyone. In this video we're going to be looking at set coils. So I was on LinkedIn the other day and there was a great discussion around whether we should use set coils and unset coils or sets and resets, whatever you want to call it, but should we be setting coils so that they stay true once the condition that set them true is no longer there? And it's a really hard concept to just discuss without visually going through something. So I've thrown a little example together and I'll take you through it and we'll have a look at why I think we shouldn't use set and reset coils. There's always a better way of doing it that's clearer. So on the screen here is an example of a set coil. And what this does is when the condition is true, it sets its variable to true. And even if the condition is no longer true, the variable remains true. So if I go ahead and set this push button 1 or PB1 to true now, we see that output 1 has become true, and so has every other instance of output 1. Now, if I go ahead and turn PB1 false again, we see that output 1 remains true. So if we want to reset the variable for output 1, then we'd need to have a reset coil, which is driven by this push button reset. And if I set that to true, we see that the reset coil sets the variable back to false. And if I unset the push button reset, we're now back in our original state. Now, this is a very basic example, and there isn't really any real reason why you'd set it up this way. It would be easier just to have push button 1, 2, and 3 ORed together and not have a set coil. But just to give an example of what we're working with and what actually happens, just for people who may not be familiar with set coils. So let's put this into a more practical and real situation. This is a small sequence that is managing 2 valves and a pump. And the idea is that the pump starts, and after a predefined period of 20 seconds, valve A opens, and that is the end of the sequence. However, if an operator presses a button, valve A closes and the pump stops, and valve B opens for a period of time before returning back to its original situation of the pump running and valve A being open. Now, this is from an example or an extract of code that I've seen in other projects. I won't name the person or the company, but basically written all with set and reset logic, controlling the actual outputs. Now, before I jump in and we go through this, I just want to stress that there isn't anything actually wrong from a logic point of view in using set and reset coils. They are very well known in programming and they get used a lot, but there are some drawbacks which we'll see as we go through this. So just to begin with, we're waiting at the moment for our push button, our start push button, to be pressed in order to set our pump output. Once that happens, we'll move on to step 1 via this branch here. And we have a reset coil here, which just resets the push button. So you can use resets even without a set to ensure that a variable is set to false. And there's nothing wrong with that at all. It's a very common way of resetting push buttons. But just wanted to explain that. So we're waiting for the push button to start, and then we'll drop down to this one here, this rung here or network here. And then after 20 seconds, we will jump to the step 10, which is down here, where we are then doing some stuff around opening valve A and waiting for other events, whether the push button for valve B has been pressed or whether the stop push button has been pressed. If push button for valve B is pressed, then we move back to step 2, which is here, and we reset the pump output, wait 15 seconds, set the pump output again, and move back to step 10. And that is the sequence. So if we run through this in real time by starting it, we now see that the pump output is set. Our push button start got reset immediately by this reset coil here, and we're now down in step 1, waiting for this time period to finish. Once this finishes, we will move immediately into step 10, which is down here. So now we're in step 10, and we can see that we're either waiting for a push button stop or we're waiting for a push button valve B. But during this period, we are setting valve A output. Now, there's no real reason as to why we've used a set coil here, but this is something that I see a lot, that for no reason a set coil has been used. So I just wanted to stick that in there and highlight the fact that they get used when they don't need to be used. So as soon as I press the push button for valve B, what should happen is we will set the output for valve B, we will reset the output for valve A, and we'll also reset our own push button and then move to step 2. So if I go ahead and push that button now, we've now moved to step 2 and our valve B is set. So if we go and have a look at step 2, we can see that we are in our timer here. We've disabled the pump output, and once this finishes, we'll set pump output again and we'll move back to step 10. Now, what we're seeing now is something slightly different to what it was before we pushed the button, which is we're back on, valve A is open. The valve B is also still open because we've forgotten to put the reset in for valve B, basically. And this is one of the problems with coils, that it's extremely easy to forget to unset a coil. Not only that, if you imagine the sequence was far bigger with many more cases that wanted to control the same outputs, or even multiple sequences that wanted to control the same outputs, it becomes a huge issue to work out where was this coil set. You know, what was the last thing that actually set this coil? Because remember, the coil stays active, or the variable stays true, even though the condition that set it is no longer true. So unless you have some sort of tracking system or debug system in place to check or record what the actual condition was that set that coil, it's really difficult to fault find. Which I think is why many people who've had a lot of experience tend to go down a different route. And we'll have a look at that now, and you can see the difference between using coils and set coils and resets, and using coils that are only ever active when the condition is still active. So in this example, we don't have any set coils. We do still have some reset coils, which are just resetting our push buttons. But from an output point of view, none of our outputs are set, and none of them are reset. So they are all just standard coils. This has exactly the same output as the previous sequence, except for the fact that we don't have a problem with valve B being stuck on. But the actual sequence itself is laid out a little bit differently. So the biggest thing to note is the way the pump is controlled. So when we're in step 1, we check whether we are equal to step 1 or greater than step 1, and that brings on the pump as long as valve B is not being requested. And then valve B down here, the transition to step 2 that controls valve B, and whilst we're in step 2 for the control of valve B, has nothing to do with the pump at this step, whereas previously we were telling the pump to stop to come into this step. And it might seem a bit neither here or there, but there is a difference in that type of control. So if we go through and step through this, if I turn on the sequence by pressing the start button, we see that we are now in step 1. So we're in step 1, and also down here we're doing another check to say, are we still in step 1? And that runs the timer to move to step 10, which is our everything's active and running step. When we transition to step 10, you'll notice that the pump output stays on. That's because this check of are we greater than step 1 is still active. And obviously pump B is not being requested yet. So if we come down to step 10 and have a look what's going on here, this is our sort of active running step. So valve A is now being requested to open. If I go ahead and press the valve B push button, we move over to step 2, which means we're no longer in this step. So valve A is no longer being output, and valve B is now being asked to open. And when I come up here to the step 1, we did see that the pump had been turned off for the duration of step 2 because the output was active, which made this a false case and turned the pump output off. But as soon as that step finished and we move back to step 10, we didn't have to set any new coils or anything like that. This pump output just became active again because this condition was now true. And this is much easier to fault find on and follow. You've got to appreciate if there were 40 devices or 30 devices in this sequence and they all had different interlocking methods such as this one. For example, we might have another 6 valves in here. I just have to add 6 more cases in here, or I can amalgamate those into a single interlock and replace valve B with the interlock that comes from all of the other valves combined. Whereas in this sequence here, it's all done like this, and this just grows exponentially and becomes an absolute mess to look after. I mean, I missed one coil just setting this one up, the reset for valve B. Imagine what it's like when you're trying to set up 30 of these and keep track of where the sets and resets are. And one of the other things that's not immediately obvious, if I were to start this sequence again by pressing the start button, so this is our set coil system. One of the things that isn't immediately obvious is when maintenance or somebody who hasn't written the program comes along and is trying to diagnose a problem in a sequence, there are a lot of people who will just change the sequence step number. In this particular case, that could lead to a dangerous situation. So we are currently in step 10 now with our pump on and our valve A on. Our valve B is also active because it's never been reset. If I come along and just change our step to step 0 again, so force step 0 in, we go back to step 0, but our outputs don't change because we've never seen the reset. So I would have to systematically go through and set all of those back to false to get myself back into a true state, or I would have to, on step 0, have all of my resets on step 0. Whenever step 0 is active, send a reset to everything, which is probably a good idea. But again, if you've got 40 devices, it's just tedious and realistically unnecessary. If I do things differently and I come and do it the way that we're showing here with no set coils. If I now change this example, we are currently in step 10 with our outputs on. If I change this one to 0, we find that all of our outputs go off. So we've got no pump output, no valve B and no valve A, and that's because we aren't setting that state. We're not looking for a reset event. We are closely coupled to the sequence, and because the sequence steps have changed, our outputs are gone, which is much safer. You need to sort of think bigger than this example. These devices may be controlled by shared sequences, where you have sequence A through to F, or different recipe batches, or whatever's controlling this. If you have something in another sequence that is setting a coil, and then somebody comes along in a fault situation and just overwrites everything and changes which sequence is now in control, well, that output is still set. And that could cause serious damage to a machine. It could cause problems in a process. It can cause all sorts of things that aren't immediately obvious, and you don't even know where it's been written from at that point because the conditions are all gone. So I'm not really ever going to advocate using set coils for that reason alone. So I hope this gives a good sort of insight into why people bash set coils so often. And I think it's one of those things that come with experience and longevity in automation with PLCs. I can guarantee that nearly everybody who says don't use set coils has a story behind why you shouldn't use set coils. And hopefully this little example has just highlighted that.